small orifice and a large orifice, circular, triangular, and a rectangular orifice, sharp edge orifice and bell-mouthed orifice, pre-discharging, drowned orifice. So there are 4 classifications of orifices are there, which we have discussed in the yesterday's class. So let us derive the equation for a orifice, open orifice. So here consider a tank where h is nothing but it is the height of water from the center of the orifice up to the free surface of liquid. Okay, so consider a tank where a circular orifice is fitted at the bottom of the tank at one side. Let h is nothing but it is the head of a liquid from the free surface up to the central axis of the circular orifice. Here, the liquid flowing through the orifice forms a jet. So yesterday I said the liquid which is coming out from the orifice is called as a jet of a fluid or a jet of a liquid. So the area of the jet, it is not constant, it is going to reduce gradually. So the area of the jet is going to reduce gradually. So therefore, at a particular distance, that is 0.5 diameter of the orifice, you are going to see the vena contracta. Okay, after that, the contraction will start. Contraction in the sense the diameter of the jet is going to. So here, consider 2 points. I am going to consider 2 points here. So let me consider 2 points. So one point is taken here and second point is taken here. Okay, so please concentrate. Here in this case, there is a rectangular tank is there where a circular orifice is fixed at the bottom of the tank. H is the head of the water at the upstream and this is the jet of water, and CC axis is nothing but it is vena contracta. So I'm going to take 2 sections. First section I'm going to take here, that is inside the tank, and second section I'm going to take outside the tank, that is in the jet of water. So now apply Bernoulli's equation for this. What is the Bernoulli's equation? P1 by rho g plus V1 square by 2g plus Z1. Simultaneously for second section, apply the Bernoulli's equation. P2 by rho g plus V2 square by 2g plus Z2. Okay, so we have taken 2 sections. First section is taken here and second section is taken here. So I am going to apply equation for 2 sections. So when you draw a datum, the height Z1 and Z2 is equal to constant. So therefore the term Z1 and Z2 are going to cancel. So finally we are going to end up with the equation P1 by rho g plus V1 square by 2g, and which is equal to P2 by rho g plus V2 square by 2g. Okay. So now what is P1 by rho g? What is P1 by rho g? Can anybody tell me what is P1 by rho g here?
Yes, ma'am.
It is H. So H is equal to, or P is equal to rho g. H is the equation. H is equal to P divided by rho g. So what is this H? It is head. So here instead of P there is P1. Which is the head available in the P1 at the first section? At the first section, which is the head? Is it small h or capital H? Which head is available here? Which is that head available at section 1? Yes. It is capital H. Capital H is nothing but it is P1 by rho g. Okay. And what about P2 by rho g? P2 by rho g equal to what? P2 by rho g is equal to what?
Small h.
It is not small h. It is, so the jet of water is in contact with the what? It is in contact with the atmosphere. Okay. So what happens to the pressure? If the liquid is in contact with the what? Atmosphere. Then what about pressure? Pressure will be equal to how much? So when the liquid is open to the atmosphere, this surface, when it is in contact with the atmosphere, then what about pressure? It is equal to 0. So since the second section is open to the atmosphere, therefore P2 by rho g is equal to 0. Okay, understood up till here? Understood?
Yes, ma'am. Yes, ma'am.
Okay. Then what about velocity? Velocity at section 1. Velocity at section 1 is the water. So think that this is a tank. The water is going to taken here. Does the velocity exist here? What do you mean by velocity? It is a distance traveled by time taken. So consider only this particular section. Does the velocity, that is water is flowing? Does the water is flowing here in the section 1?
No, ma'am.
It is stagnant. So therefore velocity is equal to 0. What about V2? The water is traveling here. It is traveling from one place to another place. That is distance traveled by time taken. So therefore V2 exists. So now the further equation will be, so P1 by rho g is nothing but h plus V2 square by 2g is equal to 0. P2 by rho g is equal to 0 plus V2 square divided by 2g. Or this term V2 square is nothing but it is square root of it is 2gh, or we can also write V2 as a square root of 2gh. So V2 is nothing but it is square root of 2gh. So this is the velocity of liquid at the second section. Okay, this is how we are going to identify the velocity. Understood up till here? Understood?
Yes, ma'am. Yes.
So this is the derivation. That is velocity at section 2 is nothing but it is square root of 2gh. So this is a simple derivation. If you're having any doubts, then you can ask me. So now, I hope you have taken the questions. Now let us discuss the hydraulic coefficients. There are three hydraulic coefficients are there. One is coefficient of velocity, coefficient of contraction, and coefficient of discharge. So what do you mean by coefficient of velocity? It is actual velocity by theoretical velocity. Okay, that is actual velocity of the jet at vena contracta divided by theoretical velocity. So this can be also written as CV is nothing but it is actual velocity by theoretical velocity. V actual by V theoretical will give you the ratio of V actual by V theoretical is nothing but it is coefficient of velocity. Then coefficient of discharge is nothing but actual discharge by theoretical discharge. Okay. So this is coefficient of discharge. In case of a coefficient of velocity, actual velocity is nothing but it is V. Theoretical velocity is, we have identified this, that is square root of 2gh. Okay, you have to remember these things in this manner. Actual velocity is nothing but it is the velocity which is identified in laboratory or practically. That is actual velocity. Theoretical velocity is nothing but we have not done any uh, experiment here. We have taken a derivation and we have calculated what is the velocity. So this derivation we have calculated in a theoretical class. Okay, so in theory we are not going to do any experiment. The value will be given, only thing you are going to equate it in this equation and you are going to calculate the value. So this value is a theoretical velocity. Actual velocity is nothing but it is the velocity which is obtained in the field. Okay, the ratio of that will give you actual velocity by theoretical velocity. And the coefficient of velocity should lie between 0.95 to 0.99. So always the coefficient of discharge, or it may be a velocity, or it may be a contraction, it should be less than 1. But the range of coefficient of velocity should lie between 0.95 to 0.99. Generally 0.98 is considered for a sharp edge orifice. So this is T, and mark this concept, that is hydraulic coefficient, as a important. Now next, coefficient of contraction. Coefficient of contraction is nothing but it is the ratio of area of the jet at vena contracta and the area of the orifice. So this ratio I have already explained while explaining you regarding the closed orifice. So it is the ratio of area of the jet at the vena contracta. So this area of the jet at vena contracta divided by area of the orifice. So area of the jet divided by area of the orifice will give you the coefficient of contraction. So now how are you going to write this? So it is nothing but coefficient of contraction is nothing but it is the area of the jet at vena contracta divided by area of the orifice. What is area? Area is nothing but it is pi by 4 into d square, the diameter of the jet. So area of the orifice is nothing but pi by 4 into diameter of the orifice. So this ratio is called as a coefficient of contraction. So CV is nothing but it is V actual by V theoretic. Okay, and coefficient of contraction is area of the jet by area of the orifice. Now what about coefficient of discharge? Can anybody tell me what will be the ratio of coefficient of discharge? What do you mean by coefficient of discharge?
Q actual by Q theoretical.
Q actual by Q theoretical. Okay, it is the ratio of Q actual by Q theoretical. What do you mean by actual discharge? The discharge which you are going to identify in the field divided by theoretical. So there are some equations in the Venturi meter, in the orifice meter. Okay, there are some equations. By using these equations, we have identified the discharge. So this discharge is nothing but it is a theoretical. The values will be directly given for you to calculate the theoretical discharge. Now, how are you going to write this Q? What is Q? What is Q? Rate
Discharge,
of
ma'am.
flow. The rate of flow.
Area
Q
into
is nothing
velocity.
area into velocity. Very good. So Q can be also written as area into velocity. Area of what? Actual area divided by actual velocity. All divided by. What about Q theoretical? A theoretical area multiplied by theoretical velocity. Now what is actual by theoretical area? This ratio is what? What is that ratio called as?
Coefficient of contraction.
Coefficient of contraction multiplied by, what is actual velocity by theoretical velocity?
Coefficient of velocity.
Coefficient of velocity. Therefore, how we are going to write CD? CD is nothing but it is CC into CV. This is very important. So these are the three coefficients: coefficient of discharge, coefficient of contraction, and coefficient of velocity. Understood? Understood the hydraulic coefficients?
Yes, ma'am.
So mark it as a important. So they may ask you in the examination for 4 marks or 6 marks. Okay. So what is the range of CD? Sorry, CV. It should lie between 0.95 to 0.99. Okay. Simultaneously, there are some values for coefficient of contraction. So coefficient of contraction value should lie between 0.61 to 0.69. Okay, in that 64 is permissible. So the coefficient of contraction should lie between 0.61 to 0.69. And what about coefficient of discharge? Coefficient of discharge varies from 0.61 to 0.65. So coefficient of discharge should lie between 0.61 to 0.65. So these are the coefficient of discharge, velocity, and contraction. That is nothing but hydraulic coefficients. Okay. So any doubts in this?
No, ma'am.
What about others?
No, ma'am.
Okay, fine. So now let us solve few problems on this hydraulic coefficients. So take this problem. A head of water over an orifice of a diameter 40 mm. Take the diagram. Sorry, take the problem. The head of water over an orifice of diameter 40 mm is 10 meter. 10 meter. Find the actual discharge and actual velocity. Actual discharge and actual velocity of the jet at vena contracta. Take CD equal to 0.6 and CV equal to 0.98. So first note down the given things here. So what all they have given? Value of H, that is head of water over an orifice. So head of water over an orifice is equal to how much? 40 mm. Is it 40 mm? Is it 40 mm? Those who are present, please raise your hands. Just tell me what is the head here. Head is equal to how much? The diameter of the orifice they have given as a 40 mm, whereas the head is 10 meter. Okay, so head is 10 meter and diameter of the orifice is 40 mm. Apart from that, they have given the value of a CD as 0.6 and CV as 0.98. So this is the given. What do you need to identify here? You need to identify actual discharge and actual velocity. Is it actual velocity? Okay. So you need to identify the actual discharge and actual velocity for this. So where does this actual velocity? So first let us solve this. So where does the actual velocity is going to? CD is nothing but it is actual velocity by theoretical velocity. Sorry, discharge by theoretical discharge. What is the value of a CD they have given? They have given it as a 0.6. So 0.6 is equal to actual discharge by theoretical discharge. Now how we are going to identify this? How we are going to identify the theoretical discharge? What is the equation?
Ma'am,
Theoretical
velocity of theoretical discharge into area of orifice.
theoretical area and theoretical velocity. So what is theoretical area? It is pi by 4 into, so area is pi by 4 into, if the diameter is 40 mm, in terms of a meter, how much it will be? 0.04 meter. So that will give you the area. So this is theoretical area. So calculate and tell me the theoretical area for this. Calculate and tell me the theoretical area. Text your answers. Text your answers. Calculate and tell me the value of a area. Pi by 4 into 0.4 the whole square. Area you are going to get it as 0.001256. So area you are going to get it as 0.001256. Is there any other answers? 0.001256. And how we are going to calculate the theoretical velocity? It is square root of 2gh. So square root of 2 into 9.81 into what is head? It is 0.04. What is theoretical velocity?
0.885, ma'am.
0.88.
58. Ma'am, head is 10 meter, no, ma'am. H.
Very good. Head is 10 meter. Now what will be the answer?
14, ma'am.
What is the unit for this? Velocity?
Meter per second.
Meter per second. What about area? It is in meter square. Okay. So CD, what is the value for CD they have given? 0.6. Actual discharge, I don't know. So theoretical discharge, how you are going to calculate? So 0.001256 multiplied by 14. So that will give you the theoretical discharge, which will be equal to how much?
0.0175, ma'am.
0.0175. What is the unit of discharge?
Meter cube.
Meter cube per second.
Second.
So it is 0.0175. Now what will be the actual discharge? 0.0175 multiplied by 0.6. Actual discharge is equal to how much? 0.1054. Okay. 0.1054 meter cube per second. So hope all of you have got the same answer. If there is any other answers, please text me. And how we are going to calculate the actual velocity? What is the equation to calculate actual velocity? CV is nothing but V actual by V theoretical. What is the actual velocity they have given? Coefficient of velocity, it is 0.98 is equal to V actual, I don't know. What about theoretical velocity? It is 14. Therefore, V actual is equal to 14 into 0.98. Thirteen point 72. 13.72. What is the unit?
Meter per second, ma'am.
Meter per second. So this is how you have to calculate the actual velocity and actual discharge. So this question will be asked for 4 marks. Okay. All of you got the same answer? Or is there any other answers? Basavaraj Pattar, Prashmita, Vaishnavi, Suraj,
Yes, ma'am.
Chaitranjali, Rohit, Rohini, Akash,
Yes, ma'am.
Prajwal,
Yes, ma'am.
Yes, ma'am.
Lynn,
Yes, ma'am.
Nikita, Parvati,
Yes, ma'am.
Yes, ma'am.
Sumaya, Shilpa, Rakshita, Praveen. Is there any doubt?
Yes, ma'am.
Yes, ma'am. No,
Is
ma'am.
there any doubts?
No,
No,
ma'am.
no.
Okay, fine. So take another problem and solve it by yourself. I'm going to give you the data. Solve it and tell me the answer. So diameter is 50 mm. Head is 12 meter. CD is 0.6 and CV is 0.98. Calculate and tell me the actual discharge and actual velocity. Similar problem thing is that they have changed the height, that is head of water, and the diameter. Calculate and tell me the answer. Text your answers. Text your answers. Akshita has got actual discharge as 0.01803. Is it correct? Is there any other answers? And actual velocity is 15.022. Any other answers? Any other answers? Okay. The other answer is 0.01808. It is a one-step problem. Praveen Sungar 14.98. Answer for actual velocity or actual discharge? Okay. So the answer for this particular problem is Q actual. You are going to get it as 0.018 meter cube per second, and the actual velocity you are going to get it as 15.04 meter per second. So all of you have got the correct answer. So take next problem. Take next problem. The answers are correct. Take next problem. So the head of the water, so here the diameter of the orifice they have given as a 30 mm, and head is 1.5 meter. Actual discharge is equal to 2.35 liter per second. Find the coefficient of discharge. Find coefficient of discharge. A very simple problem. So convert this liter per second in terms of a meter cube per second. Equate the values and tell me the answer for CD.
Oh, Momo! Mummy!
Savraj, please mute your mic. Tell me the answer for CD. It is a very simple problem. CD is nothing but Q actual by Q theoretical. Actual discharge they have given 2.35. Convert this into meter cube per second. So how are you going to convert it?
Divided by 1000, ma'am.
Into 10 power minus 3.
So calculate and tell me the value of a CD for this. So Q actually is 2.35 liter cube per second. Actually is theoretical area multiplied by theoretical velocity. Theoretical area, how we are going to calculate? A theoretical, it is pi by 4 into 0.03 the whole square. And V theoretical, you are going to calculate it by taking square root of 2gh. CD value for this particular problem, you are going to get it as okay. Rakshita Nayak has got 0.615. What about others? Any other answers? Any other answers? 0.63. Okay.
Mm.
0.676127. Okay. So the answer for this particular problem is 0.613. That is CD value. So all of you have got the correct answer. 0.61, 0.63 or 0.6127 or approximately 3. So Rakshita, Praveen and Shilpa, you have got the correct answer. So take another problem for assignment. Similar problem, only the data is going to be changed. Here, the diameter is given as 20 mm and head is 1 meter. Actual discharge is 0.85 liter per second. Okay, identify the coefficient of discharge. Similar problem with a different data. So while coming to the next class, come with the answer. I hope many of them have solved it already. Okay, fine. So this is all for today. In the next class, I will be explaining you the experimental determination of hydraulic coefficients. So students, there are two types of hydraulic coefficients are there. The hydraulic coefficients which we have discussed today, that is CD, CV and CC. So these are theoretical. Okay. So the experimental determination of hydraulic coefficients, I am going to explain you in the next class. So this is all for today. Hope, I think there is no doubts in this. So we'll meet in the next class. Thank you.
Thank you, ma'am.